This test method can be used to determine the air content of any type of concrete, including lightweight, normal, and heavyweight concretes. This test method will determine the amount of both the entrained and entrapped air voids in the concrete. Air entrainment is necessary in concrete that will be exposed to cycles of freezing and thawing and to de-icing chemicals. The microscopic entrained air voids provide a source of internal pressure relief within the concrete to accommodate the pressures that develop as ice crystals form in the pores and capillaries of the concrete. Without the proper air content in the mortar fraction of the concrete, normal concrete that is exposed to cycles of freezing and thawing will scale and or spall, resulting in a durability failure of the concrete. However, care must be taken not to have too much entrained air in the concrete. In concretes designed to produce 3,000 to 5,000 psi compressive strength, as the air content increases, say above 5%, there will be a corresponding reduction in the strength of the concrete. Typically, this strength reduction will be on the order of 3 to 5% for each 1% of air content above the design value. For example, a concrete proportion for 5% air will be approximately 15 to 25% lower in strength if the air content rises to 10%. This test method covers the determination of the air content of freshly mixed concrete containing any type of aggregate, whether it be dense, cellular, or lightweight. This test method covers the determination of the air content of freshly mixed concrete. It measures the air contained in the mortar fraction of the concrete, but it is not affected by air that may be present inside porous aggregate particles. Therefore, this is the appropriate test to determine the air content of concretes containing lightweight aggregates, air-cooled slag, and highly porous or vesicular natural aggregates. This test method requires the addition of sufficient isopropyl alcohol when the meter is initially being filled with water, so that after the first or subsequent rollings little or no foam collects in the neck of the meter. Addition of alcohol to dispel foam at any time after the initial filling of the meter to the 0 mark is not permitted. As with any hydraulic cement concrete testing, always wear the minimum proper protective equipment required. The sample must be obtained in accordance with ASTM C172, sampling of freshly mixed concrete. This test method is applicable to plastic concrete if the concrete contains coarse aggregate particles that would be retained on a 1 1/2 inch sieve. Wet sieve a representative sample over a 1 inch sieve. Dampen the interior of the measure and place it on a flat, level, and firm surface. Remove any standing water from the bottom of the measure. Fill the measure in 2 equal lifts. Rod each lift 25 times, uniformly over the cross-section, with the rounded end of the rod. While rodding the first lift, rod the layer throughout its depth using care not to damage the bottom of the measure. After rodding, tap the outsides of the measure with a rubber mallet 10 to 15 times to close any holes left by rodding and to release any large air bubbles. For the second lift, rod the layer throughout its depth and approximately 1 inch into the previous lift. After rodding, tap the outsides of the measure with a rubber mallet 10 to 15 times to close any holes left by rodding and to release any large air bubbles. After rodding and tapping of the second layer, strike off the excess concrete with a strike-off bar until the surface is flush with the top of the measure. Wipe the flange of the measure clean. Wet the inside of the top section of the meter, including the gasket. Attach the top section to the measure and insert the funnel. Add at least 1 pint of water followed by the selected amount of isopropyl alcohol. The amount of isopropyl alcohol necessary to obtain a stable reading and a minimum amount of foam immediately above the water column will depend upon a number of factors. Many concretes made with less than 500 pounds per cubic yard of cement and air contents less than 4% may require less than 1/2 pint of alcohol. Some high cement mixes made with silica fume that have air contents of 6% or more may require more than 3 pints of alcohol. The amount required will vary with the air content, the amount and type of air entraining admixtures, the cement content and cement alkali content, and perhaps other factors. Generally, the amount of alcohol necessary can be established for given mixture proportions and should not change greatly during the course of a project. Record the amount of isopropyl alcohol added. Continue adding water at least until it appears in the graduated neck of the top section, preferably near the 0 mark. Remove the funnel. Adjust the liquid level until the bottom of the meniscus is level with the 0 mark on the graduated neck. A rubber syringe is useful for this purpose. Attach and tighten the watertight cap. Quickly invert the meter, shake the meter horizontally, and return the meter to the upright position. To prevent the aggregate from lodging in the neck of the unit, do not keep it inverted for more than 5 seconds at a time. Repeat the inversion and shaking process for a minimum of 45 seconds and until the concrete has broken free and the aggregate can be heard moving in the meter as it is inverted. Place one hand on the neck of the meter and the other on the flange. Using the hand on the neck, tilt the top of the meter approximately 45 degrees from the vertical position with the bottom edge of the measure resting on the floor or on the work surface. Using the hand on the flange to rotate the meter, vigorously roll the meter 1/4 to 1/2 turn forward and back several times, quickly starting and stopping the roll. Turn the meter about 1/3 turn and repeat the rolling procedure. Continue these procedures for approximately 1 minute while listening for aggregates sliding in the meter. Set the meter upright, loosen the cap, and allow the liquid level to stabilize. The liquid level is stable when it does not change by more than 0.25% within a 2-minute period. If, at any time during the inversion and rolling procedures, liquid is found to be leaking from the meter, the test is invalid and a new test shall be started with a new portion of the sample. If it takes more than 6 minutes for the liquid level to stabilize, or if there is more foam than the equivalent of 2 full % air content divisions on the meter scale over the liquid level, discard the trial and start a new test using a new portion of the sample and a larger addition of alcohol than was used in the initial trial. If the level is stable without excessive foam, read the bottom of the meniscus to the nearest 0.25% and record this as the initial meter reading. If the air content is greater than the 9% range on the graduated neck, add a sufficient number of calibrated cups of water to bring the liquid level within the graduated range. Read the bottom of the meniscus to the nearest 0.25%. Record the number of calibrated cups of water to be added to the final meter reading. When an initial meter reading is obtained, retighten the top and repeat the 1-minute rolling procedures. When the liquid level is stable, read the bottom of the meniscus to the nearest 0.25%. If this reading has not changed more than 0.25% from the initial meter reading, record it as the final meter reading. If the reading has changed from the initial meter reading by more than 0.25%, record this reading as a new initial meter reading and repeat the 1-minute rolling procedure. Read the indicated air content. If this reading has not changed by more than 0.25% from the newest initial meter reading, record it as the final meter reading. If the reading has changed by more than 0.25%, discard the test and start a new test on a new portion of the sample using more alcohol. Disassemble the air meter by detaching the top section from the measure. Allow the liquid to discharge from the air meter. Dump the contents of the measure. Examine the interior of the measure to be sure that there are no portions of undisturbed, tightly packed concrete present. If portions of undisturbed concrete are found, the test is invalid. If more than 2 1/2 pints of alcohol is used, a correction to the final meter reading is required. Round the volume of alcohol used to the nearest 1 pint and select the correction factor from the correction factor table. Calculate the air content and report it to the nearest 0.25%.